Okay, guys, so Unit 2 study guide. Everyone has it out? Everyone's ready? Okay. So, first thing you need to be able to do is calculate molar mass. How do you calculate molar mass? You need the periodic table. Good. So if I gave you, I think this was one of the examples. So this is letter B on that first step. Okay. Okay, so you have ammonium phosphate. You need to calculate the molar mass of that. What do you do?
Molar mass and coefficient.
Okay, you don't need the coefficients, you need your subscripts, right? Remember the little numbers, your subscripts. So you need to take into account each piece. Piece meaning each element. So in this case, you've got nitrogen, hydrogen, phosphorus, and oxygen. The trick to this is figuring out how many of each element you have. So how many nitrogens do you have? 3, because you're distributing that 3. So the mass of nitrogen, you would look on the periodic table, is 14. Hydrogen, how many hydrogens do we have? 12. 3 times 4 is 12. And the mass of one hydrogen is 1. Okay. How many phosphoruses do we have? 1. That's 31. Oxygen, how many oxygens do we have? 4. Good. Times 16. So when you add all those together, I got 149 grams per mole. Okay? Questions? So you need your periodic table. The trick with these problems is making sure you distribute your subscripts. Okay? Wonderful. Next page. Okay. So, percent composition. Let's just, okay. So 54 was saying what's the percent composition of phosphoric acid? So percent composition, Ben, how do you calculate percent composition? What's like the general formula? Sean? Perfect. The part over the whole times 100. Okay? In this case, the whole is your molar mass, which we just talked about how to calculate. The part is each of these elements. Okay, so first thing you would do, same thing you did for your molar mass, because you need the molar mass. So you have 3 hydrogens times 1, 1 phosphorus, 4 oxygens, and when you add that all up, you get 98 grams. So the percent composition then is each piece. So hydrogen, you would do 3 over 98 times 100. Phosphorus, 31 over 98 times 100. And then oxygen, this is 40, 60, I think, over 98. Okay? 64, sorry. 64. So then you get 3.1%, 31.6%, and 65.3%. Okay? However many elements there are, that's how many percentages you should have. Okay? Questions with that?
What was that one?
You got it? It's always the part over the whole times 100. So first thing you would need to do is calculate the molar mass. That'll get you started. Then you've done all the work. You just have to put it in its pieces. Okay? Okay. So then the next one is empirical formula. Okay. So, empirical formula. You guys should already have this formula. The poem, percent to mass. mass to mole, divide by small, and then multiply till whole. Okay. Do you guys want me to do the problem on here? Yes? Okay, sure, I'll do it. Okay, so it said that you had 0.545 grams of aluminum. Oxygen, you had 0.485 grams. So because they're already in grams, you don't really even have to do the first step, okay? The first step is percent to mass. So if you already have mass, you've done step one. Okay, if you're not, if you're given percentages, you just do what? You just put grams behind it. Good. Okay, so percent to mass, we've done that. Mass to mole, that's just one step going from mass to mole. Divide by the molar mass. So on the periodic table, you'd find 27 grams for aluminum, 16 grams for oxygen. You get 0.020185, 0.0303125. Then what's the next step? Divide by small. So in that case, you just pick whichever one's the smallest and divide all of them by that number. So I got 1.5 and 1. So we did percent to mass, mass to mole, divide by small, multiply till whole. These are supposed to be your subscripts now. If they are not whole numbers, you need to multiply them until they get to a whole number. So in this case, I always think of it like you have 50 cents. So what do you have to multiply that to get $1? 2. Good. Whatever you do to one, you have to do to the other. So then these become your subscripts, and you're looking at Al2O3. Okay? Questions? Okay. Mole to mole stoichiometry. Let's see. Mole to mole. If you're given moles in the problem and asked for moles, that's how you know it's a one-step mole to mole problem. So it gave you 2CH4 plus S8 yields 4 H2. Okay, so this is your chemical equation. So if you're given a chemical equation, you're using stoichiometry. Okay, and the problem's asking, it gives you 1.5 moles sulfur, and it's asking for moles of carbon disulfide. So you're going this way. So always what you were given over 1, it's only one step. Whatever units are up here have to go down here. So moles of S8, what you're solving for, moles. Then what numbers do you use there? So you're in moles, going to moles, you what? You plot for coefficients. So what number's in front of your sulfur? 1. You got 2 there, so you're just multiplying them out and you get 3 moles. Right. So if the problem gives you moles and asks for moles, this is the only thing you can do. And again, let's make sure I do this right. Okay. So it's always moles of what you were given goes on bottom, and what goes on top is moles of what you're trying to solve for every single time. Okay? This is general. That's great. Okay? Okay. Next problem. Okay, turn the page over. Ha 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 ha. So, The next part is the mass to mass. This is the most complicated. There's only one of these on the test, so if you're still struggling with this, that still gives you an A. Okay, so keep that in mind in perspective. Okay, so it tells you, okay, let me write out this big long problem. You will always be given balanced equations. That you do not need to worry about. Ooh, okay. So I'm just going to do one of the 4 problems. Every single one it gives you, it says that you start with 380 grams of oxygen. Okay. So let's go to water. Water's a nice easy one. Okay. So that's, what are the steps? The steps are the same every time when it gives you mass to mass. You go from mass to moles, moles to moles, moles to grams, every single time. So that's 3 steps. Okay. First step, you're going from mass of oxygen to moles of oxygen, so you're going to be, what? What are you using now?
For what?
Going this first step. So you've got grams of oxygen to moles of oxygen.
Oh, you do your molar mass on your.
Good. Your molar mass. So your molar mass here is 16 for 1 oxygen, and you have 2 of them. So that's 32. You do not use your coefficients when you're doing just mass to mole. The only time you use your coefficients is in the next step when you're going moles of one substance to moles of what you're solving for. That is where you use your coefficients. Clap for coefficients. So in front of your oxygen you have a 3. In front of your H2O you have a 2. And then now that you're in moles of the substance you asked for, it asks for grams. So you just have to multiply by the molar mass of that substance, which you guys have already calculated out. You probably have it memorized by now, is 18. Okay? So when you put all that in your calculator, you should have gotten 143 grams of H2O. Okay? Do you guys want me to write out in general the steps for this every single time? Yes, would that be helpful? Okay. Do you guys have this written down? Okay. So, I don't like yellow. Let's change to purple. No. Ooh, I can choose colors? Yeah. Okay. So, in general, solving mass. Ooh, no. No. Okay. Let's try this again. So, solving mass to mass problems. I will get this straightened out, guys. Okay. So every time it's what you're given in grams over 1. Okay. Then you're given grams on the bottom and you're using your molar mass for 1 mole of your given. Okay. Then your moles of what you were given going to moles of what you're solving for. And here, what are you using? Your coefficients. Good. Let's see if I can write this sideways. Ha! Look at that. Okay. Now once you're in moles of what you're solving for, you were just multiplying by the molar mass of what you're trying to get to. Okay? Over 1 mole. If you follow this formula every single time for mass to mass, you should get it right. Okay? Good. Moving on. Where am I at? Mass to mass, we did that. percent yield. Okay, last one. Here we go. So your percent yield, this will be just like it was on the quiz, okay? In general, the formula for percent yield is your actual over your theoretical times 100. So your actual yield is what you collected in the lab. So you're looking for keywords like collected, you made. Theoretical is going to be what you calculated. So you did some homework, this is what you should have made, this is what you calculated to make, okay? In this case, probably in this class, it's always going to be the smaller number over the bigger number. Yes, so smaller number over the bigger number, right? Times by 100. That's how you solve those problems. Okay. On the test, I will write on the board and give you 1 mole equals the molar mass. 1 mole equals 22.4 liters, and 1 mole equals 6.02 times 10 to the 23rd. Okay? 10 questions, I will give you partial credit, but if you show no work, you get no credit. Even if you're just a good guesser. Okay? Questions? You guys feel a little bit better about this? Looking around the room, you guys look like you're doing pretty good. Okay? Okay, great.